to have the AWS AI Observability Summit. We'll get started in a moment. Just a couple notes for housekeeping. So for those of you who will ask, because there always are people asking, we will have a recording of this session that will be distributed within a week. So first we're going to get started with Sherry and Sajid, and then after that I'm going to wrap it up kind of with a demo and a little bit of an overview of what LLM observability looks like and can do for you. Um, Basically, I think we're ready to go at this point in time. Sajid and Sherry, are you two ready?
Yeah,
We are.
All right, I'm going to stop sharing in a moment here and then I'll hand it off to you, but I think we're good to go.
all
All
right.
right.
I can kick us off. I'll start with just a brief introduction of myself. I'm super excited to be here. My name is Sajid, one of our VPs of engineering here at Datadog, leading all of our AI ML products. Been at Datadog about 6 years, and really primarily have kind of a software engineering background. But for the last several years, have been really leaning into all of our AI ML products, including Watchdog, as well as sort of some of our newer generative AI products like Bits AI, which is sort of our autonomous SRE for automatically resolving and helping teams resolve incidents as they come up. Yeah, that's me. Sherry?
Hi, everyone. My name is Sherry Marcus, and I lead Bedrock Science for AWS. Bedrock, as everyone might be aware, is AWS's marquee generative AI service where customers can choose from one of many models and create a Gen AI application. My role is really developing the all the application, capabilities and some of the model capabilities such as agents and guardrails and RAG, as well as many different model compression capabilities such as, fine tuning or model distillation or routing. So very happy to be here and talk with you about Gen AI and our great work that we're doing together with Datadog.
Awesome. So yeah, I think Sherry and I actually managed to have a similar conversation a few months ago, talking a little bit about sort of the importance of AI observability at Datadog's earlier Dash conference. And it's funny, I think that was only, 4 months ago or something, and it feels like the industry has continued to move sort of at a blistering pace since then. I know we've invested a lot more in our generative AI products, and in particular in sort of the evaluation and observability of those. But I'm curious to ask you, Sherry, sort of I think it's sort of interesting. Like, I think we're been an interesting sort of conversation pair because I think you get a really broad view, Sherry, of like how the entire industry is using
Mhm.
Bedrock and models across a ton of different, applications and industries. And I, with our team here at Datadog, have really been kind of diving deep in a couple of really key use cases. And so I'd love to just ask you, like, in the last sort of 6 months, how have you seen the space evolve, and how have you seen sort of customers mature in terms of bringing like LLM based products to market?
Yeah, that's a great question. Thanks for asking. I would say, if I could go a little bit broader in the timeline, from when, the Gen AI explosion happened, customers, came to us and asked, okay, what is Gen AI? How do I get started? And that was probably definitely last year in 23. In this year, it's been really all about questions have really been maximizing this golden triangle of accuracy, latency, and cost. And so, we've been working with, the, industry at large, figuring out, uh, given a specific requirement, whether it be, customers, call centers or, different kinds of financial applications, how large of a model do you want? What is your accuracy, specifications, and how do we, minimize cost and minimize latency for your specific application? That's really been, the biggest change. It's really been all about that.
Yeah, I think that makes sense. And I think even, again, actually, Datadog, we also have a similar perspective where we have an LLM observability product that we're selling into the market. And I think we've also really seen that as well, right? I think it's funny, like I think as soon as all the generative AI sort of blossom that happened, as you said, like everyone's sort of known that it's going to be a huge effect on the industry, but it's probably a transformation that's going to take several years to happen. And so I've just been really impressed at seeing like how quickly the option's going and how much further we are now, again, versus a few months ago. And I think as that
Mhm,
happens, cost has definitely become a far larger sort of question for our customers as well, right? Since early on, I think a lot of folks were trying to figure out, hey, like, is there a product I can build here? Will it be useful? And there was a lot of that focus on quality. And frankly, that's where it was for us at Datadog as well. Like
mhm,
our early products were in beta for a few months, and then I think the first few things that we GA'd were really in the incident management space. This is sort of Bits AI, again, our autonomous agent that will automatically help you resolve incidents and issues in your infrastructure as they come up. And so the first things we really GA'd are things like summarization and postmortem generation. Um, and those at first we really were focused on just the quality just to make sure it was good, but as those sort of scale out and more people use it, and we start to push more into things like natural language querying, right, like letting folks actually define their Datadog queries in you know basically natural language, right? Saying like, hey, like can you tell me like have errors increased on this service without having to like go and look up exactly what the names are of all the different fields that you want to query and all that. Um, we've focused much more on sort of efficiency and cost, and it sort of really entered that equation in a way that it was just sort of secondary in 2023.
mhm, 100%.
Um, so yeah, I
What,
mean, go ahead.
yeah, I'm just curious, what have you seen in terms of, multimodal, LLM, Gen AI application needs and how that has evolved over the last 6 months?
So yeah, I mean, I think so we've seen it, and again, from sort of two perspectives, right? There's our customers and like what we're building internally at Datadog. I think with multimodal, I think folks are usually talking about sort of images and video, or sort of the two other modes beyond just text generation, that folks tend to focus on, and we're seeing that within our LLM observability product. Like I think text is definitely the furthest along to market in terms of what we see, but I think image generation has also um, picked up considerably. Within Datadog itself, we've actually started to think about multimodal in a few different ways. So again, traditionally, there's like sort of the text mode is kind of one sort of mode.
Mhm,
Um, but at Datadog, we're starting to think about modalities like time series data,
mhm,
which uh, yeah, like is distinct, right? Like I think there's sort of this stereotype of like LLMs aren't that great at math, and we're actually seeing that there's actually quite a bit of really interesting work happening now to make LLMs better at sort of formal reasoning. But there's another element of what we're focused on Datadog, which is like, okay, if you've got an enormous amount of data, time series data, where you can see things like, okay, what's my CPU usage, memory usage, lag, et cetera, how do you um, what's the best way to have models sort of understand that data so they can begin to reason about what that data is saying? And so we've started a research effort at Datadog, and recently, I guess now it's been a few months, wrote a technical report on a new kind of class of foundation models called Toto, um,
mhm,
time series optimized transformer for observability.
yeah.
That's really us sort of diving deeper into, yeah, like I said, this time series modality, and trying to see how we can do in the same way that like the foundation of LLMs are really sort of predicting the next word, the next token. Um, for us, this is sort of the foundation here is like, okay, given a set of data, time series data points, can we predict the next, tranche of data points, the next sort of epic of data points? Um, but just like with the LLMs, you can sort of take that really simple task of just predicting the next token and actually do far more. We're now starting to explore research on like, okay, now that you have sort of time series forecasting, can you also do like anomaly detection?
Mhm,
Combine it with language models to do things like sort of to do explanations, basically. Can we feed
right.
Toto, just like a huge variety of data. So that's sort of the other area that we've been kind of diving. It's a sort of a less common modality, I think, in the market, but something that is domain specific for Datadog that we hope will ultimately deliver value for our customers.
Yeah, yeah. What domains are you finding time series LLMs being the most applicable? Is it finance?
So for no, for us, we're doing it primarily for observability, right? To help our
Okay.
customers. Like, so we actually do a number of time series. We do have a lot of time series forecasting in Datadog today, right?
Yeah.
So this is, the really simple use case is alert me, you know, a week before my disk runs out of space,
I
right?
got it. Yeah.
Or I think the one that's far more compelling and we've been working on, which is like, okay, um, I've got to start monitoring a bunch of infrastructure. It hasn't really been monitored before, and I now need to set up, you know, monitors to alert me when we have an anomalous amount of errors. And so you need to then develop a model as to what is an anomalous amount of errors. And that's really
Mhm.
valuable for our customers, right? If they can sort of click a button and just get monitoring over like hundreds of services, thousands of services, and have monitors that are well tuned that alert them when there are real problems, but not when, there aren't. Um, that's sort of the application why we're diving deep into time series forecasting.
Got it. Got it. And sorry, my finance background, when I hear that, I always, click to that. But I'm curious because in various things I've seen in like image analysis, like VLMs are beginning to outperform like traditional AI. So I'm curious for the time series forecasting that you've been doing using LLMs. Have you seen like comparable outperformance, with like traditional non-LLM based, stations?
I mean, I think that's a really interesting research question, one that we've started to look into because yeah, like this has been one of the like common critiques of sort of applying deep learning to time series forecasting is that
Yeah.
is it actually like, there are some papers that will show that like the deep learning techniques are better than like the more traditional like ARIMA models, et cetera. But then you look a little bit closer and you're not sure that like they've really fully tuned the ARIMA models, like really kind of done their best with the classical techniques so that there's a
Mhm.
fair comparison. And so this is some of the research we're doing right now, is sort of comparing like our very highly tuned domain specific classic models against against sort of the newer techniques. Uh, we don't have anything to announce there, but I think that that is precisely that question, especially when you look at that sort of triangle that you talked about,
Yeah.
latency, cost, and quality. Some of the traditional models are actually very good on latency and cost, and so it's sort of a taller order, right? You have to be able to say like, okay, um, is there a particular sort of domain where we can really get much better quality because like you have these like multi-billion or even 100 million parameter models. It's just fundamentally compared to the classic models which are much smaller. It's going to be harder to compete on latency and cost. And so the area where I think we're most optimistic is sort of what we call this cold start problem. Right? Like, and this is sort of the same idea, which is you can do an enormous amount of pre-training in LLMs and then get a model that's like very general and can actually do a lot. So can we similarly do a lot of pre-training and teach a model enormous amounts about how to understand, specific domain-specific observability metrics like Postgres metrics and Kafka metrics and Kubernetes metrics, such that when a customer comes in and we have no history for them at all, can we still do a good job of figuring out what's anomalous, right? In the same way
Mhm.
that like a human can, right? Like traditional systems really need several weeks of data to understand seasonality, et cetera, before it can identify something that's anomalous. But a human
Mm.
kind of knows what like Postgres connection lag or some specific or like the number of connections open to a Postgres database. If they see a sudden spike, they don't really need to know the weekly seasonality to know that that's problematic. Uh,
Yeah.
so
Yeah.
that's the area where I think we can do much better than sort of traditional classic approaches.
I agree. I agree. I'm very excited to follow your results, and see the great things that y'all come up with.
Yeah. Thanks. Um, I'm curious actually, like as we think about sort of, I think a lot of folks on this call are probably interested. They themselves are trying to get LLM products into production, and they're trying to figure out
Right.
like how they should be monitoring it and understanding the quality of it and how it runs in production. I guess I'm curious for the customers using Bedrock, do you have a sense of like how they tend to approach ensuring quality, right? Like especially,
Yeah.
yeah, go for it.
Yeah. So that is our number one question, all right, that we get from customers is, one of Bedrock's, value propositions is we offer model choice, right? And customers come and ask us, well, how do we, one, evaluate the models, right? And then two, evaluate the applications, right, that we want to run the models in. So we are rolling out new capabilities in model evaluation that we've been working with customers on, model evaluation and then application, evaluation. So the first model evaluation, looks at typical benchmarks that you would expect to see for, given customer tasks, whether it's like QA, just conversational AI type of gens, math, and we, not only against the public benchmarks, but we have, been collecting, thousands of prompt responses for each of these different types of tasks. So we're able to discriminate these models above what public benchmarks are actually showing, which has been super, super helpful, right, to figure out, which models are fit for purpose. The second thing is, in the area of completeness and, faithfulness of the model. So, and this is within the application area. So if you're running a RAG application for retrieval, is the model like, hallucinating, or is it faithfully, responding to a message to a prompt from the source data? We also have been adding things into such as responsible AI, right? And detection of different types of prompts, within your application that you want to be able to you don't want, right? To be able to answer and spend that inference. So these are the kinds of things that we're rolling out and doing. If you're interested, certainly connect with me. Definitely happy to talk about. But model evaluation, to me, and I'm just speaking on the accuracy piece, as the first, right? The second is in the area of latency and performance, and we also, offer different benchmarks and testing to look at latency cost as well. The third area is we're providing, new tooling coming out in the area of model distillation and routing so that customers can distill models, take a large model and, distill it into a smaller model for cost, as well as at inference time, route a prompt to a model that is as cheapest. So, and we do a lot of different evaluations with customers to help, optimizing that. So, so the answer is like, yes, we spend a lot of time in evaluating against those three factors.
Yeah, that makes sense. And I think it really tracks a lot of our sort of our journey with Bits AI as well, where I think, again, early on, when you're really just trying to find a product that works, you've got to figure out like a sort of a golden data set or sort of a benchmark data set where you can figure out like, okay, here's the product I want to build. Here are some examples of it working well. Like, let's track and see how we're doing. But now, as we've moved more and more of these products into general availability with a lot of folks, the focus, that continues to be a major sort of the golden data set sort of continues to be a major sort of driver of how we do development, but there's a lot more sort of focus on this kind of online evaluation as well for a couple of reasons, right? A lot of it is sort of model drift, right? As like usage changes and like there is, one thing that we see is like I do see an enormous amount of drift because there's a lot of changes to user behavior, right? Like, you launch something and people have like sort of low expectations of what it can do, and the moment you sort of start to meet the like I don't want to say low expectations. They actually have very high expectations compared to what we would have thought a couple years ago. But the moment you meet them, their expectations shift further and further ahead. And so we've noticed that user behavior and user expectations are just moving so quickly when it comes to sort of AI assistance, agentic systems. And so making sure that you have sort of an online view of what's working has been critical for us. And And then the second thing that you mentioned that really resonates is that, again, there's really just been such an explosion of different models, and in particular, like distillation as well, right? So both in the context of, customers kind of distilling their own models, right? Starting with a larger model and distilling it into a small model for their purpose, as well as you see a lot of the major model providers doing that for you, essentially, right? They're all providing models in sort of different sizes. And so at some point, as like my team kind of got tired of me slacking them to be like, hey, this model just came out, like, how are we doing, how are we doing?
Yeah.
We just sort of had to take a moment and kind of stop and just really level up our kind of observability and evaluation so that they weren't in a place, so that we weren't on our back foot, right? Basically, that
Right.
when there's a new model, um, we're much more quickly able to run a few specific benchmarks. I will say that it has been challenging. Like our real end-to-end benchmarks, like if you want to evaluate, like, is Bits a good autonomous SRE? Like that's quite complicated, right? It's similar to like sort of software engineering. Like, can you build a great software engineering agent? Like the best
Mhm.
benchmarks today are, or at least the most commonly cited benchmarks today, are basically based off of bug fixing, right? You have like a set
Mhm.
of issues, and you have a set of PRs that fix those issues, and you use that to benchmark. But a lot of folks here, I think, are experienced in software engineering. That's actually a very small slice of what it means to be a software engineer. Um,
Mhm.
and so we've had the same problem internally where we have a set of benchmarks that are sort of very quick and very easy and lets us get a quick sense of how a model will perform on a set of tasks. And then we have another set of
Mhm.
benchmarks that are far more complicated and it becomes more difficult.
Mm.
It becomes more difficult for us to like run it on every model because each sort of run of the evaluation is actually kind of a large, many hours or even days long undertaking of just running, you know, evaluations over and over again in many runs. Because again, the stochastic nature of inference means that you have to do, sometimes thousands of runs to get the variance where you want it.
100%. 100%. Um, and I agree that, as customers are looking to, swap models out, being able to do these evaluations, it needs to be relatively, while it may take, lots of inference calls from the customer's point of view, it needs to be, one or two clicks and very simple to make these kinds of decisions in swapping out.
Yeah, I think that's right. And like, I guess the next level of maturity, which is again something we see a lot of customers working towards, and we're working towards itself, is that model routing, right? Like I guess what I
Right,
was talking about is like, oh, new model came out, should we switch to it? That's a very sort of static process, or
right,
that happens at sort of like developer time. It's like, oh, like should we try, the latest revision to this model,
right,
and like swap it out versus should we dynamically like at request time figure out what's going to be the best bang for buck on this question? Is it an easy one where we can use a small model, or
right.
a larger one? And that's definitely one of those things that I think is going to be subject to drift in terms of usage, and
Yes,
really want to make sure that you have like good continuous online evaluation for that.
yes, yes. Offline and online evaluation are definitely uh, two different problem, areas, very related. In terms of, distillation, and then we could talk about model routing. Distillation is where you have a larger model called a teacher model, right? Which, given a set of prompt response pairs, is used to train a smaller model, usually within the same model family, but not necessarily, for a given set of tasks, right? And that's called vanilla distillation. And there are a lot of techniques that, we've seen in data distillation and data augmentation where where you can improve the accuracy of these student models or the smaller models above vanilla distillation, and this all applies for specific tasks, right? And the prompt response pairs tend to be the customers. So when you're doing that kind of model, changing out a model for a smaller model, there's a lot of nodes there, right? Because you're fixing tasks, you have the customers, prompt response pairs, and then you can continue to monitor the results. Now, for automatic routing, you have is different, right? You have a customer's input prompt, right? And then you have a model, a trained model that's trying to evaluate, should I send this to the bigger model, right? Or to the smaller model, right? And so there you really it's also based on task, right? And customer input prompts. And then you're really trying to evaluate the complexity of the prompt, right? And there we have also found several good techniques, for the model to evaluate. And so as a simple example, right, if your input prompt is asking an agentic workflow, like you see a lot of API requests for API calls within the prompt, more likely than not, you're going to take it to a bigger model because it's going to be a more complex workflow. But if you see maybe a shorter prompt length, potentially, it's going to be more of a smaller model.
Yeah, makes sense. I think we're at time for our portion, so I'll hand it to Ryan to kind of continue us from here.
Yeah, no, that was great. I didn't want to interrupt, sorry. But I think we do have a couple of questions in the QA that I wanted to get to if we've got time. So the first one that I had here was from Norman Katz. So he's asking for Sherry. In addition to the which one is the cheapest algorithm to select a model, have you seen use cases where you want to get results from several models and aggregate them? And in his case, I think he's thinking of medical decision support prompts, for example.
Yes. So one of the techniques that we're using, and also you'll see more results, is LLMs as a judge, right? Where you have several different models. So you may have like a Claude model or a llama model and a Mistral model, and you're looking at those aggregated answers, together, from the model. Now LLM as a judge looks at the responses, is asking those models to evaluate, the completeness of of the target model that you're trying to evaluate. And the value there, is that, like, just unlike programmatic prompts where you're just looking at like the accuracy, with LLMs as a judge, you're looking at the verbosity, all right, of it. Maybe you're looking at the true completeness, right, and the bias of it. So it has it is several more factors, okay, that you're using to actually evaluate the veracity of the model. Again, connect with me. I'm happy to show you some of those results. But to me, depending on what you're looking at, I would recommend LLM as a judge, and as perhaps 70 or 80% of the time, I would use that as an evaluation method versus just the reward model, preference-based evaluations.
That's perfect. And we had one follow-up to that, if we can. So what about monitoring results in production? So if there are cases where the result is not accurate or hallucination, there is actually a few questions on this.
Yeah.
And I think you were kind of getting onto that point as well.
Yeah. So Bedrock offers guardrails hallucination, where we will look at the source data, the provenance, and validate that the provenance that the response is faithful, okay, to the actual provenance. And so that's a capability, that you can turn on. And that, in addition to our evaluation, which can like look at the completeness and all of the other factors, the bias, responsible AI that you might want to look at in your answers, is what we would suggest moving forward. I will say, okay, that the responses are only as good as the data that you have available, right? And what the model is trained on. So if it's not there, right, it's not there.
And the one thing that I would add is on top of Bedrock, one advantage to using a system like Datadog sort of LLM observability is if you want to take some of that similar data about hallucinations and guardrails and sort of contextualize it in a larger application. Like if you're using application performance monitoring within Datadog, and you've got like a series of prompts that are kind of chaining each other, and the result of one ends up being the input to another, or maybe your like LLM application then provides an input to like some other sort of more traditional application. Um, Using something like LLM observability, which Ryan will talk about a little bit more, can kind of help you kind of put together that larger picture as well, which is particularly useful for agentic systems where there can be like a very complex sort of sequence of prompting and response that kind of ultimately leads to one user interaction.
Yeah, definitely. So there are quite a few questions in here. I'll try to pick but one last question if we can. So Mahantesh asked two. Mahantesh, I'm going to pick the first one if you don't mind. So the question is, if an organization likes to build or implement observability platforms with AI capabilities in mind for enterprise financial institutes, with a diverse tech landscape, so that's on-prem, hybrid, or what have you, cloud workload in AWS, what are your suggestions around how to go about it? What are the minimum details or prerequisite required to start the conversation? So I think this, to me at least, is like there's a lot of people in organizations asking like, what can we do with these tools? Seems to be the gist of what we're asking, or how to get started.
For sure. I mean, I can start with that. Like I think it is a complicated landscape, right? And particularly in the context of sort of enterprise applications. Again, I think you want to look at one thing. One thing I would say is just sort of contextualizing it, right? Like in terms of what your LLM application is doing, like is it sort of a standalone thing or is it tied in with other systems? And making sure that you're sort of, yeah, again, there's value to like sort of narrowly observing the LLMs, but again, oftentimes they tend to sort of fit into larger customer flows, right? Like maybe it's a customer service flow or a checkout flow, and you want to be able to like contextualize not just like, oh, was this response good, but like, did the user actually ultimately check out of that cart or place that order or whatever else it was? I think that's a critical thing to keep in mind. Another critical one is just sort of is data security, right? And if you're dealing with with LLMs mostly operate on text data, which can be some of the most sensitive types of data, right? There's could be a lot of PII, et cetera. And so you want to make sure that you have a solution that you kind of trust to handle that data well and will be able to do things like, sort of redact some of the most sensitive data that if you want to make sure that that doesn't end up in your logs and retained for longer than you'd like. I mean, there's a million more things there, but those are sort of two of the critical things that come to mind for me.
And Sherry, sorry to tee you up, but are there things in Bedrock that can help in that regard as well when it comes to PII?
Oh, 100%. In our guardrails service, we offer PII redaction, and this is both at the prompt and the response level. And our results, our benchmarks are, bring us to SOTA on that for that specific requirement, as well as other bias or inappropriate prompt pair responses.
That is perfect. I think we're okay for questions. There were quite a few more in the chat. We'll try to get to those in a bit. But thank you so much, Sajid and Sherry, for joining us today. That was fantastic.
Thank you.
Thank
Thank you.
All right, so I'm just going to quickly share my screen here. Sorry, folks. And we'll switch gears here. So we should be able to see my desktop now. And then I think what I'm basically going to go into is sort of dovetail from what we were just talking about and kind of think about what this means in practice. And I'm going to be talking about LLM observability for a bit, but I want to make sure you understand that I'm talking about observability for LLM applications. And then I'll talk about the Datadog LLM observability after that. All right, so I'll introduce myself. I'm Ryan McLean. I'm a senior tech evangelist at Datadog. I've been with Datadog for almost 5 years at this point. Prior to that, I was a senior engineer at Samsung, and I've been using Datadog for over 10 years. Now, I think we can all agree when we say the excitement around LLM tech is more than a passing trend. However, given how often we hear terms like AI, Gen AI, and LLM, it can feel like not using AI in your business might be a misstep. So basically, if people are asking you, why haven't we done this yet, kind of thing, or where would this fit in our workflow, as Sajid was mentioning, like as part of a bigger application, where would this fit in? And integrating those Gen AI and language models into your applications enables you to build powerful tools for sure for data analysis, intelligent search, text and image generation. But there are a number of tools that you can leverage Gen AI and scale it according to your business needs with specialized technologies such as vector databases, development platforms, and even on something like AWS, discrete GPUs if you're doing something like tuning or fine tuning. These can be necessary to run many models, but the advantage of using something like Bedrock is that it's an API that you can call as you're using the Gen AI models. Now, as a result, optimizing your systems for AI often leads to upgrading your entire stack. However, doing so means reevaluating your monitoring needs as well. Otherwise, you risk adding complexity and silos to your observability strategy with the rapid introduction of new AI technologies. All right. So the first question is like, why Datadog for observability? So I will say, at least in terms of third party, we are named a leader in the 2024 Gartner Magic Quadrant for observability platforms. Also, the main goal here is that Datadog will solve complexity. So Datadog is a monitoring and analytics platform that helps companies improve the observability and security of their infrastructure and applications. We offer generative AI observability capabilities to allow teams to deploy LLM-based applications to prod with confidence and help troubleshoot health, cost, and accuracy real time. Now, Datadog's LLM monitoring not only tracks usage metrics, but also provides insight into how they perform. So a lot of the questions in the chat were, what does performance look like? And that can be something like latency or accuracy. And as Sherry mentioned as well, the third part of that triangle would be cost. So what we can do is alert organizations to issues such as prompt hijacking, unexpected results, and more. Now, finally, we give you this end-to-end observability, including LLM, on a single unified platform powered by shared service and AI/ML. From infra monitoring to APM to real user monitoring, log management, security, all the way down to the developer experience, monitoring code not only in prod, but also it's being built. Okay, so before we dive into LLM observability as a whole, that's what we'd want to do in terms of observing a piece of generative AI application as part of our bigger business problem. I want to set the stage with some background context. So when I've delivered content like this before, we'll get questions like, what is an LLM, or what is observability, or why do I need this? Why is it important? What is the complexity? What is the landscape that I'm landing into if this is something like a brownfield as opposed to a greenfield deployment? So if it's a new deployment and there's less complexity, what does that look like? Or if it's an existing business application that we're shoehorning something into, what does that mean? What does that entail for us in terms of the entire application? Now, when you lead into tech innovation, you're faced with an explosion of complexity. I've been in the industry for a while. I think it's almost 25 years at this point, probably coming up on 30. But when I started, there were basically a few vendors that you could go to for software applications. And these days, as things are growing in maturity and complexity, we're getting lots of open source or software as a service companies coming into play. We're also getting things like going from physical hardware into cloud instances and scaling on demand with containers and moving to microservices. The amount of nodes or the amount of containers that you're looking at can increase, or even the amount of lambdas or the functions that you're running as a service. Furthermore, the amount of deployments that you're doing, I'm not sure if you recall what this looked like 20 years ago, if you've been in this long as I have, but it could have been something like a yearly deployment. So it might be something that you deploy once a year in the case of a big business application. As we move forward to things like mobile applications or on-demand websites, or things like single page applications where you can update these on a regular basis, you could be at a point where you're deploying on demand. So as things are coming out, you're deploying smaller pieces, but maybe deploying to microservices as part of a larger stack as things come up. So that complexity in terms of deployment is also increasing. Now, for the keen-eyed of you, you've probably noticed that there's a multiplication point between each of these, but as this complexity grows, so does the entire complexity of the system. And then finally, we've got the number of people involved. So as you're moving from, let's say, a traditional operations team into something like maybe more of a DevOps or a DevSecOps, or maybe even bringing in FinOps or the business into your deployment planning and your production maintenance, you're going to have more people involved, and that network effect further influences the complexity. Now, this is prior to even talking about implementing something like Gen AI into your stack. And as we move into that, you see that this is a familiar slide, but we've got two slides on the two charts on the right talking about AI. So one shows the wealth of the new LLMs over the year. You can see how fast it grows. And this is from 2022. But if we look at something at even just the foundation models that Bedrock serves is increasing exponentially. We've got things like Llama 2, 3.1 coming out on a regular basis. So it might be quarterly you need to look at this. And as Sajid mentioned, there could be newer models that you're trying to like test yours against. So the complexity of what you're doing internally for the model that you're developing or fine tuning can also become more complex. And then finally, the second is a proxy to the amount of inference power available in the world. So I think in terms of CPU architecture, we can think about things like x86 or ARM. So doing maybe more for the amount of power that you're using, or maybe you're using more systems or like a larger cluster. In this case, we're using iPhones as a proxy for performance, but you can see how quickly it's increasing. Now, the question is, why does this compound complexity? And in short, it's because of the enormous amount of data and processing it needed to achieve differentiating results with AI models. All right, so just a quick overview of LLMs on their own, because we did this question last time I delivered this content. So a large language model is a computational model designed for tasks related to natural language processing. And Sajid kind of touched on this a little bit as we were talking through before. Basically, what it might be doing is sort of thinking about the next word or maybe the next portion of a word if we're thinking of tokens as you're typing. So if you used an editor before for editing code, you're probably familiar with as you're typing the code, it may suggest different things to you. We can think of that as like a smaller example of a bigger problem. Now, when we're talking about something like audio or maybe video, it might be a little bit different in terms of what we're actually delivering, but let's try to keep that mental model in our mind. So what it's doing is acquiring these abilities by learning statistical relationships from vast amount of text during a self-supervised and semi-supervised training process. And again, Sherry mentioned that there could be actually another model evaluating for you as well, as opposed to something like a human in the loop. So it can be quite complex in terms of what you're actually delivering. But the main thing to remember is what it's kind of doing is predicting what that next token might be, or again, to think of like a portion of a word. Now, I mentioned this because we're going to be talking about LLM observability. So there are some problems that revolve around prediction. So if I'm trying to be an oracle or trying to decide what comes next, I could be wrong. If we think about something like the weather, it's very difficult to predict the weather. It's getting easier and easier, but there are cases where like a farmer's almanac might be more accurate than something like a prediction model, funnily enough. And it might be that you need to go from multiple sources in order to get to something that's more accurate or more precise. So what is large language model observability? So since the release of LLMs, Gen AI has quickly become more integral to aspects of business, finance, security research, and language than ever before. Now, while the adoptions of LLMs has experienced a significant boost, running those applications in production has proven to be more challenging compared to traditional ML applications. So if we're thinking about like big data or something like that, or maybe you've been doing ETL before or traditional ML, it might be that you're used to predictability, for example. So this difficulty arises from the massive model sizes, intricate architecture, but also the non-deterministic outputs of LLMs. And what I mean by this is if I ask the same question twice, I might get a similar but not exactly the same answer. Furthermore, troubleshooting issues originating in LLM apps is a time-consuming and resource-intensive task due to the black box nature of the decision-making processes. Okay, so managing LLMs requires more continuous monitoring to guarantee sustained performance and security while producing those precise and unbiased responses. And LLM observability, and we're talking about this practice as a whole, not the Datadog version, but in terms of what you want to be doing when you're running LLMs in prod, it'll provide tools, techniques, and methodologies to help teams manage and understand your LLM application and language model performance from your app, talking to something like Bedrock and the foundation models, but also maybe you're running something on EC2 with a GPU instance, and you're running your own or you're doing fine tuning. What we can do is detect drifts or biases, but also resolve issues before they have significant impact on the businesses or the end user experience. Okay, so we've kind of set the stage for the context. So what it is and what we're trying to do. But then it comes up like, what are the issues? So we talked a little bit about drift. We talked a little bit about security, but there are a few terms for these that we can go over. So as artificial intelligence and LLM tools are in their infancy, there are a number of issues that can occur. both prompted by users and within the LLM's responses on their own. So a proper LLM monitoring tool can help organizations keep track of those issues that might occur within LLM applications, such as hallucinations, performance and cost, prompt injection, security, privacy, and response variants. So we touched on these a little bit, but I want to dive into each of these in particular because we want to talk about how we solve for it. So LLM-powered applications may occasionally produce false information, and we call this phenomenon hallucinations. So basically, imagine that you've asked this assistant for an answer, and instead of saying, I actually don't know, it may confidently respond with incorrect answers, which get confusing. So rather than acknowledging their lack of knowledge, they frequently yield responses that may appear assured, but that are essentially flawed. So very confidently saying, "Hey, the weather tomorrow is going to be rainy," but it's not. Like there's no indication that rain's going to happen, or there's no data that would actually help the model tell you what the weather will be tomorrow. This propensity can potentially foster and spread the inaccurate information, and that consideration is crucial when applying LLMs to activities that necessitate factual accuracy. So some of the questions in the chat were things around like finance or healthcare, for example, where the accuracy is really important. And maybe for something like whether it's okay to be wrong every other day or something like that, but it depends on what the application is or what your business resides on, or maybe the risk factors involved in the actual application. And often the applications built using LLMs rely on third-party models. So for example, in Bedrock, we could have the first-party models. So those are the ones from Amazon Titan, for example. But there also might be a third-party model. So something from like AI 21 Labs or maybe Cohere or something like that that you're using for RAG or retrieval augmented generation. But this dependence can lead to issues such as performance degradation. So let's say we've moved between Meta's Llama 3.0 to 3.2, and we've noticed that the responses are much faster, but they're not as accurate, or the amount of tokens that we're getting back are different. It's not to say they're better or worse, but they're different. And this this change, I guess, in the models as time progresses or as they mature can lead to inconsistencies due to changes in the algorithms and can also affect your costs, as Sherry mentioned. So maybe Meta Llama 3.2 is less costly in terms of the actual output that we want, but perhaps it's not as accurate. So we need to look at that golden triangle. So Sherry said we've got the golden triangle of accuracy, latency, and cost. And I'm going to use that a few times because I really do like that approach to talking about where the benefits are for your business. And obviously, depending on the amount of data volume, this can be even more serious. All right, so the other one we've got here is that prompt injection is a technique where user can influence the LLM apps to produce specific content. So this manipulation can potentially cause LLMs to generate inappropriate or harmful material. Awareness of this issue is vital, particularly when deploying LLMs in customer-facing applications. So not behind the scenes, but something where a user may or a client may actually see the output of your application. Okay, so the other is LLMs pose security issues, including potential data leaks. We talked about PII before, output biases due to skewed training data, and risks of unauthorized access. So depending on what we've trained the model on. And additionally, LLMs may generate a response containing sensitive or personal data. So stringent security measures and ethical practices are vital when dealing with LLMs. And finally, the user prompts received by LLMs and the responses they generate vary in attributes such as length, language, and accuracy. And we were mentioning within the same model family, there could be different versions, for example, but also we could be looking at different foundation models and how they may differ between each other. Users may also receive different responses to the same query. That could lead to confusion and inconsistent user experience. So this enforces the need for continuous monitoring and logging of the LLM applications. All right, so just to wrap up, so there are a few common issues, so hallucinations, performance and cost, prompt injection, security and privacy, and response variants. And the question is it worth deploying these applications, even in something like a beta or a smaller release? And what can we do to start addressing these? And again, we're just talking about the problem set in general. So not Datadog, but if we're thinking about this problem set and we want to land this in our production app, what do we need to think about in order to make sure that we're addressing these risks because they are important? So as the tools rapidly evolve, organizations that implement in-depth monitoring of their applications can expect the following benefits. So we talked about performance before, but LLM observability would enable real-time monitoring of various performance evaluation metrics such as latency and throughput of the LLM application, as well as quality of the responses. By continuously monitoring these metrics, data scientists and engineers can quickly identify any deviations or degradation in LLM performance. So if we're talking about what Sherry mentioned in terms of having an LLM look at the output of other LLMs or maybe multiple LLMs, that differs than having a human in the loop. So an engineer that's paid to essentially watch all the output. And imagine scaling that. That would be quite difficult, right? This is why you'd want to watch it as you go real time to make sure that you're addressing these issues. This proactive approach will allow for timely intervention, leading to improved model performance and user experience. All right, so with LLM observability, you can get deep model insights into the inner working of the LLM applications. And by visualizing the request response pairs, so that's like what you've put in your prompt. So why is water blue, for example, and then you get the response back. So that's a request response pair. Also word embedding. So if we're talking about something like retrieval augmented generation, and you've got a corpus of data that you're feeding into a model in order to populate a vector database and then actually pull up those word embeddings when we're trying to do searches or prompt chain sequences, LLM observability will enhance the interpretability of those responses, and that increased transparency will enable your stakeholders to trust the LLM application's decisions and identify any quality issues or errors in the application's outputs and logic. So another refrain that we saw in the chat that was quite popular is, how do we trust the accuracy of what's being spit out? How do we make sure that what we're asking for is giving us the right answers, basically? And what does that performance metric look like? How do we measure the quality? The other is end-to-end visibility into the operation of an LLM app is essential to resolve issues such as incorrect or no response at all. So I'm not sure if you've ever tried this before, but sometimes when typing in something to a model when you're testing, for example, you may get an answer that uh, it may be an answer. So we get like a response 200 okay, but it could be either empty or contain an answer that doesn't actually address our question. So this is pretty key because LLM observability will enable engineers to analyze the backend operations and those API calls to something like Bedrock for requests to pinpoint the root cause of those issues. And that'll reduce the time it takes to resolve an issue. Okay, so before last year, we've got security. It's one of those things that I guess as we're shifting left as we go through our maturity process and something like platform engineering, or maybe we're thinking about FinOps, DevOps, DevSecOps. LLM observability will play a crucial role in enhancing the security of those LLM applications by monitoring model behaviors for potential security vulnerabilities or malicious attacks. Now, I've got a demo at the end, and I'll talk about what some of those look like, but some of them are like obfuscating your prompt in order to get something out of the LLM. And by tracking out these access patterns and input data and model outputs, LLM observability tools can detect anomalies that may indicate data leaks or adversarial attacks. And this continuous monitoring helps data scientists and security teams proactively identify and mitigate security threats, safeguarding sensitive data and maintaining the integrity of LLM apps. So the long and the short of this is, at the very least, look at your logs, but ideally you want to look at your logs wholesale and look at patterns. So are you getting attacks on one specific IP, or maybe a geo IP, so it's a country-based attack, or maybe it's something like a certain type of user is doing this attack, and perhaps it's something that you want to handle in your front-end code. Maybe it's something that you also want to handle in Bedrock, or maybe it's something that you want to learn about in sort of a trial phase and then apply in either of those, either or of those areas later. So the question is here, if it might be something like a honeypot kind of thing. So you set up an app to figure out what the attacks might look like, and then based on that, set up your application. But also, as it's in production, going from like a staging to prod sort of workflow, maybe you want to in prod make sure that you can do things like have a deny list for IP addresses that are continuously hitting your application. All right, and finally, cost management. So observing the resource consumption and utilization of these LLM models will allow organizations to optimize resource allocation and cost based on actual usage patterns. So the worst case scenario is if this becomes sort of shelfware. So you're paying for Bedrock, you've got a great model from Anthropic lit up, and no one's using it. And it could be that what you're doing is actually just essentially leaving money on the table because it's not being used to the level that you expected, or it could be that it's such a hit that you're spending way more than you expected. And it might be that you need to find a right fit, or perhaps have varying levels of service depending on where in the app they are, and picking models that may be better better suited to what the users are asking and providing less token usage as a result. So by monitoring metrics such as token consumption, as mentioned, and if you're using something like EC2, CPU, GPU utilization, something like the API calls themselves to Bedrock, memory usage, those observability tools can help in identifying resource bottlenecks or underutilization. So these insights can inform decisions on scaling resources up and down. So let's say your model's not being used as much as you want, so you could scale down, or perhaps you're using like a cluster of EC2 instances, or maybe something in Kubernetes or EKS, you can scale up as well. But the goal is to ensure cost effectiveness of the LLM applications that you're deploying. Okay, so this is a bit. What I really wanted to do is cover the problem, like the landscape of what's actually going on. So again, so the problem space is we could ask a model a question, and it could be that we get responses that vary in terms of the latency required, or the latency that takes to give you the answer. The other could be that the explainability of what happens could be difficult, so we're addressing that. The next is when issues occur, we want to have the mean time to resolve to be as short as possible. Furthermore, as security shifts further and further left, we want to make sure that that's on the forefront of what we're thinking about when we're deploying these applications. And finally, doing all of this with costs in mind. So a cost-informed approach to deploying this new tool as part of your application stack. Now, if you want to get started, I would highly recommend grabbing this repository from the AWS samples on GitHub. Basically, what it will do is walk through like a knowledge base setup for Bedrock, and you can use Datadog to monitor this. You could use something else if you want to. I'm going to demo how that would look like in Datadog with our LLM observability tool. But again, remember those problems that you've got in mind. So think about those what ifs. So when you're deploying the sample app, think about what your internal users might use if this is like an internal knowledge base, or your external users might use in case they're doing something like looking up warranty or tech support. Think about those use cases and how you might address those issues that might arise, because it could be way more complicated than you expect, but also it might be a little bit more simple in terms of deployment when you're using something like Bedrock as an API, when you can create those calls from something like a Python and JavaScript app, as opposed to having to host that on your own in an EC2 instance and then talk to it. All right, so that's the sample repo. It's similar to what I'll be talking about, but just imagine that you've got an app with sort of a chat interface, and users are using it and asking a lot of questions, but also it's open to the public. So there's people trying to attack your website, that kind of thing. It's the standard operating of a production platform on the web. Okay, so I'm going to quickly look at the screen here, but basically this is LLM observability from Datadog. It's in beta. We're going to talk a lot about the traces view here, but there are also clusters and dashboards views for you. I want to make sure we know that this is all out of the box. So this isn't something that I had to set up. As soon as you light this up with your AWS integration and you have the SDK installed in Python, you will start getting this data when calling Bedrocks, which is fantastic. So there's quite a few things you can do. So we talked a little bit about latency, errors, transaction saturation, that kind of thing. We can also look through the durations. We can just look at errors if we want to. We can drill down into each of these calls. You can kind of see some of the text samples here. We can also look at just dev if we're starting off in dev and moving to prod. We could look at something like staging, that kind of thing, QA. But the main thing I want to concentrate on are these quality checks. And this addresses those issues that we were talking about. So things like failure to answer, negative sentiment, positive sentiment, if that's good, or toxicity. And what I'm going to do here is in the reader view, kind of look at the prompt and response pairs that we were talking about before. So in this case, that the multiple question marks may indicate that this is a negative sentiment, for example. Now, the other is if we want to look at all of the ones with negative sentiments, we can start drilling down into that problem to see if this is something that we're seeing a lot. The other is something like toxicity or maybe prompt injection. Here we can see that somebody's trying to use base64 to sort of confuse our model. And it might be something that we want to track on a regular basis. Again, this could be something related to one IP or one area or one user type, but we want to know that. And it might be something that we want to handle on the front end, but it could also be something that we want to handle on the back end. So we talked a little bit about guardrails in Bedrock, for example. All right, the other here is positive sentiment. So maybe this is one of those things where we want to see what's actually happening in terms of the green, the happy path, basically, as users are using your app. And finally, we've got toxicity. So sometimes we can have users talking to the LLM foundation model in a way that it's sort of not friendly, basically. And we can start bubbling those up to see if there's something that we can do maybe in our app to avoid these responses, or perhaps it's something that we can do in our model to make sure it doesn't happen. Now, again, we can drill into any of these for like a time frame or drill into the problems as we want to. I'm just moving my mouse around here, but you can drag or click into it. And as you click into these, we can sort of drill down into the errors. So we can see that this had a spike. We want to know, hey, why was there a spike here? We can start looking at things like the duration by application, volume by application, if we think that this is going to affect our cost. But the last one here is just, as we're going through these, remember that you can single out all of these. You can look at them as a bubble up, but you can also grab these graphs and add them to your own dashboards as well. So again, these are built in. So when we're looking at duration by application, that kind of thing, these are all part of LLM observability, but it might be something that you actually want to add to your own dashboard. And I'm just going over some of the metrics here. So P95 at 4 seconds, it might be cause for concern, but it also might be something that we consider normal right now for LLM observability. The other is it could be that the unanswered ones are actually a pretty big deal. So when we're asking questions of the foundation model and not getting answers, maybe that's a bigger deal than taking 5 seconds. But I'll just remind everybody that in the past, loading a website could take about 10 seconds. These days, I think we expect around 1 second. And perhaps as these models mature, the expectation from our end in terms of how long it takes to respond may become larger and larger. So we expect it to get down to that either real time or 1 second kind of response. Now, to learn more about LLM observability, sorry, I should have been on this slide here. We have a knowledge center, which I think does a pretty good job of covering LLM observability as a whole. We've also got a pretty good article on talking about monitoring Amazon Bedrock with Datadog. And then finally, just talking about Datadog LLM observability on its own. There's a good blog post in the monitor there for you. Okay, so again, this recording will be sent out in about a week in case you didn't get these links, but let me know in the chat if there are any questions about the resources. But I'll quickly hop into questions. We're a little bit over time, but it's not the end of the world. So I'll try to handle about 3 of these here. Okay, one of the bit.ly links gives you a 404 arrow. Okay, I'll try to find that as we're chatting. My apologies. So in terms of questions we've got here, failure to answer metric that was manual input from the user after they received a response from the LLM, i.e. a thumbs down. So no, in this case. The failure to answer might be something like a response 200 that contains an empty response. So that's an easy one. The other failure to answer might be that the LLM confidently gave an answer that was either incorrect or didn't address the user's question. So it might be like the LLM will produce something that's response 200, okay, so API, good to go. The answer might be, I'm sorry, Gustavo, I can't answer your question because I don't have enough data. That is a response, but it failed to answer what we had asked. And sometimes that's pretty easy to detect based on what the LLM is giving you in terms of an answer. But it might be that it's a little bit more complicated than that in terms of how we know that it's a failure to answer. So it's not just an empty response or a failed response. Those will catch, but also a response that includes some text that doesn't address the answer. Okay, and I think we had a little bit more in the chat here. And my apologies, I'm just going to bring up the Bedrock samples repo. I may have messed up my bit.ly link. Okay, so that's in the chat. Yes, Deepika, sorry, that was a bit fast-paced. I tried to go slow and tried to keep the amount of material pretty light. I will say there is a recording, though. I tend to talk fast when I have coffee, but I would say if you watch it at maybe a slower pace or pause as you're going through it, it should be good. I think also a lot of the chat in the beginning with Sharon and Sajid was pretty like like a lot of detail as well. So I'd highly suggest going through it. I know I certainly learned a lot. So I would say the recording should help out. Sorry, we went a little bit fast there. Anything else? Okay, copy of the presentation. Yeah, we'll send out a recording. Excellent. Okay, I think we've yes. Okay, so Saba Toth asked if the knowledge base is the reg, and I think somebody answered that. But yes, basically there are quite a few samples in here that should be able to address like the getting started kind of use cases. But also I would suggest specifically the knowledge base ones that uses reg. Okay, so I think we've got everything. So lastly, I want to thank you all for coming. This was fantastic. So I've got a couple of links. If you'd like to sign up for a Datadog trial, if you're new to Datadog, there's a QR code on the left and a short code in case you'd rather use that will take you there. So just to sign up for a trial. The other is if you're in New York City, October the 29th, I'd highly suggest joining us for a curated dining experience at the Resident with an insightful discussion featuring Sherry, Director of Bedrock Science at AWS, and Sajid, VP of Engineering for Product Platform at Datadog, who you've heard from before. They will share their perspectives on what makes AI truly transformative, strategies for incorporating it into your products, and how to scale AI applications in prod with comprehensive observability. So scan the QR code on the right in order to attend. I think we've addressed all the questions. All right. Thank you very much, folks. I'm just going to quickly stop sharing, but that was fantastic. I hope you all have a great day. And thanks for all the questions. That was great. All right, folks, have a great day.